Hello again, pre-algebra students, sorry. Today we're going to talk about another kind of a transformation called a rotation. And a rotation is where we are turning a shape around a fixed point. That fixed point is called the center of rotation. And that center of rotation for us is always going to be the origin. We're never going to use any other point. So they might say that it's going to be turned about the origin or around the origin, but it's always going to be using the origin as that center. So you can see here they took a picture of a flag and they put point A as the center of rotation. That's like holding your finger at that point and then turning the picture or the paper around that one point. So point A is at the bottom right corner of this flag. So when they turn it 90 degrees, and these are clockwise rotations, the way a clock goes. So the flagpole goes from the left side, and then after 90 degrees, it's on the top. If we would go another 90 degrees, so it's 180 degrees, now the flagpole's over on the right-hand side. This is like turning it halfway around. So you can see it's different than a reflection, but it's rotating halfway around. And then if we would do another 90-degree rotation, we're at 270 degrees clockwise. I want you to also notice that 270 degrees clockwise, can you see that that's the same as 90 degrees counterclockwise, the opposite way that a clock goes. So when we're doing these, again, we're going to be turning our pictures. They are still going to be congruent. It's not changing the size, it's not changing the shape. It's just going to be facing in a different direction. So this slide, I hope, isn't too confusing. And remember, you guys, you should be following along in your note packet for these. For the rotations where we're going clockwise, these up on the top of the slide, clockwise rotations. That's where we're going from the blue triangle to the green triangle. So for a 90-degree clockwise rotation, I'm going to pick, instead of having that same arrow that they've got right there, I'm going to go from this top point. They're going there. 90 degrees moves it one quadrant. So a 90-degree clockwise rotation is just going to go from quadrant 1 to quadrant 4, for instance. Then for 180 degrees, you can see the arrow that they've got here, but if we go like from that same top point, that's moving 2 quadrants or halfway around. And then for a 270-degree rotation, again, it's going here 3 quadrants, 3/4 of the way around. Notice now they took those exact same pictures and they just changed the arrows, really. So a 270-degree clockwise rotation that we just looked at, when we look at a 270 degrees counterclockwise rotation, so they're going in the opposite direction now. So they're going from here counterclockwise, they go around this way. I do want to point something out. Personally, I don't usually do very much with 270 degrees. I would rather look at a 90-degree rotation in the opposite direction. So for this one, a 270-degree counterclockwise rotation is the same as, let me use that green marker again, it's the same as going 90 degrees clockwise. Or back up to this last one for the clockwise, 270-degree clockwise is the same as a 90-degree counterclockwise. So I tend to focus more on the 90s than using the 270s. You can see that the 180 rotation looks exactly the same. So it doesn't matter if I'm starting at the green one and going to the blue one. Because it's 180 degrees, it's halfway, I don't care if it's going clockwise or counterclockwise. Will not matter at all. For my 90-degree counterclockwise, again, this is the green to the blue this time, 90 degrees counterclockwise is going to go that way. These are the rules from your pink sheet. I really want you to have your pink sheet available when we're doing all these rules. So you should have your note sheet, you should have your pink sheet, and you should have your worksheets ready when we're done. We have these rules. I'm going to have 2 ways to show you this. One way is by using the rules that I personally really like, and another way is with paper turning. which is nice, but it's a little harder for me to show without being in person in front of you, but we'll do our best. The 180 is the easiest one to do. So we're going halfway around. So again, remember, it doesn't matter if I'm going clockwise or counterclockwise. The rule is every ordered pair is just going to change signs for both numbers. So the rule says multiply both coordinates by -1, right? I'm reading right here, multiply both by -1, but it's really just changing the signs. So for instance, this point right here, that's at 3, 4. When I rotate 180 degrees, that point is going to come to here, which is going to be at -3, -4. Change signs, okay? For 90 degrees, now this one, they don't say it specifically, but this is a 90-degree clockwise because you can see that arrow is going this way. 90 degrees clockwise, so I'm going to look at this rule right here. By the way, 90 degrees clockwise, we just talked about how that is the same as 270 degrees counterclockwise. I'm okay with that abbreviation, okay? And I might as well just write this as long as I'm on the rules. 90 degrees counterclockwise is the same as 270 degrees clockwise. That's already written on your paper, but it might be a little hard to read. If we're going 90 degrees clockwise, here's the rule, and I want you to write this down on your notes, please. It says multiply each x coordinate by -1 and then switch the x and the y coordinates, which kind of is a little confusing. So here's what I want you to do. We're going to change the x and then we're going to change the order. So when I say change the x, that means I want you to change the sign on whatever x you have, and then you're going to change the order. Okay, so for instance, let's go back to this same point right here, 3, 4. What I have right now for my x is a +3. If I change that, it'll be a -3, and I'm going to change the order. So I can just write the 4 down first, and then it'll be a -3. And if I look at this ordered pair, it is at 4, -3. That works, okay? So you can use the rule. I'm going to talk about this note down here on the bottom in a second. But let me tell you the rule for the 90-degree counterclockwise. I don't want to use that same point this time because I already used that point twice. So I'm going to start with this point right here. When I rotate 90 degrees counterclockwise, that's going to go right there. And again, the rule for 90 degrees counterclockwise is change the sign of the y and then change the order. So write this down, please. Change the y and then change the order. So this point, remember this one, we started with the green one. This point was at 1, -3. When I change the y, now it changes to a positive, and I'm going to change the order. So that's going to go first. So it's going to be at 3, 1, which does work. Now, there is another way to do this by turning your paper and looking at what your shape looks like and then turning your paper back and regraphing it. I'm going to show you that in a minute, but these are the rules for how you do it. I don't really care which way you do this, whichever way you feel more comfortable with, but we're going to practice both of them. So let's start this one with just the rules. So this is 90 degrees clockwise. Okay, 90 degrees clockwise. If you look at your pink sheet, that says I'm going to change the x and then I'm going to change the order. Okay, and if you want to write that down, you certainly can. I'm not going to uncover these rules where they have their work shown because I think it's a little confusing at first. I would rather just look at these problems. So for point A, I'm at -4, 3. I'm going to change the x, so now it's +4, and I'm going to change the order. So it'll be 3, 4 for A prime. For B prime, I'm going to change the x, so now it's positive, and change the order. So B prime is at 1, 1. For C prime, I'm going to change the x, so now it's +4, and change the order. So it'll be a 1, 4. Okay. I would just write those down personally, and then graph those. So A prime is at 3, 4, 1, 2, 3, right there, A prime. B prime is at 1, 1, and C prime is at 1, 2, 3, 4. So right here is my new image. There it is, looking a little bit better than what I have. But the rules, the way that they write this, showing the work, I think is a little bit confusing. Personally, if I were you, I wouldn't even worry about this part right here. Okay, so we're going to do this one by turning a paper. I can't switch to my document camera to show you this, but you have your paper in front of you. I did find a way that I think is going to work here pretty well. Excuse me. So I want to rotate 270 degrees clockwise or 90 degrees counterclockwise, right? Either way is fine. So here's the thing. I took that picture and I've got another one of them right there. Okay, so I can rotate this just like you can rotate your paper. So if I want to go 270 degrees clockwise, again, 270 would be like this. I would go 90, 180, 270. Okay, let me rewind that for a second. Instead of all of that mess, I could do this and it looks exactly the same. Okay, so right there, I just rotated my paper 270 degrees clockwise or 90 degrees counterclockwise. Now that I see what this looks like, I can just graph those points, right? So I already had point C on here. Point C on my graph, it's gonna look a little bit weird, is at 1, 2, and that's where they have it right there for C prime. Point A is at 5, 2. So I would come over here, 5, 2, that's gonna be A prime. And then B prime is gonna be at 4, 4. B prime, right there. And you can see how that matches up with what I started with. And I have it right there as well, okay? You can then, after you graph it, you can write down the ordered pairs, okay? If you have this just on your own paper, what you're gonna have to do is turn your paper like this to see what that looks like. Does everybody see on this one right now, this looks like it's in quadrant 1. It was in quadrant 4. So when I look at this and I look at point A and I say, oh, that looks like it's at 5, 2, what you'd have to do is then turn your paper back and then graph that point at 5, 2. Okay, back to another rule. And honestly, again, for the 180s, I totally love the rules. So what I'm going to do is I'm going to take those ordered pairs that I have, and it's already graphed for you, that original pre-image is, and then I want to rotate 180. Remember, the rule for rotating 180 is just change all the signs. Every single sign changes. So instead of -1, +2, I'm going to have +1 and -2. Instead of 2, 3, I'm going to have -2, -3. And instead of 3, 0, well, the 3 will change to a -3. There isn't a -0. Again, the work is just multiply everything by -1, but I do not expect you to ever write down that work. Once you have those ordered pairs, then it's easier to graph this. So my original graph is here. X prime is going to be at 1, -2. You can see point X was in quadrant 2. Point X prime is in quadrant 4. It's halfway around. Point Y is going to be, or my Y prime is going to be at -2, -3. And then point Z is at -3, 0. There we go. And there's a picture that looks way better than mine. But that's doing it with the rules. Again, 180, I love the rules. Here's another one, doing it with paper turning. Okay, so you're going to be turning your paper. I made another copy of this so that I can rotate it. Well, we have to first be able to read the problem, I guess. So we've got this shape that's already graphed. I want to rotate it 90 degrees clockwise and then get my ordered pairs. So here's my original shape. When I go 90 degrees clockwise, turn it the way that a clock goes, 90 degrees. All right, so J looks now like it's at the point 2, -3. So 2, -3, here's J prime. Point K right here looks like it's at 4, 1, 2, 3, 4, 5, 6. So 4, -6. 2, 3, 4, 1, 2, 3, 4, 5, 6. K prime. M looks like it's at 2, 4, 6, 7, -6. 2, 4, 6, 7, 2, 4, 6. And then N looks like it's at 7, -3. So when I graph this, you should be able to see that it looks like the shape that I had when I rotated. And then you'd be able to write down those ordered pairs. Okay? The last slide is just one more time looking at those rules on your pink sheet. I personally like the rules, but I also see that at first, paper turning is probably going to be easier for you. I really don't care which method you use. On the worksheet today, the first 6 problems are just giving you different rotations. A lot of them are 180 rotations, which is really nice. And on the back side, there's 2 more problems where you have to decide what the rule is. If you're rotating 90 degrees, 180, or 270, and then what direction you're going on those. Make sure that you're looking at the original points and the primes so you know which one is the new one, so you know which direction you're going. If you have any questions, let me know.